Friends, welcome. My name is Jim Lookabaugh. I'm with the Network Services Division at Internet 2, and I am very happy to see you here today to help wrap up a terrific week at Community Exchange. What we have for you this afternoon is going to be a terrific story shared by our panelists on ANA 100G, its story and its evolution. You're going to hear from the folks that were there behind the scenes putting it together, and I'm going to introduce the moderator who will then introduce you to the panel. Our moderator today is Marc Lyonnais from Ciena, and I welcome him to the podium. Please help me welcome Marc.
Does that work? Yes? Good. Good day. Last session. How can that be cool, talking about how we brought the community together. So I would like to welcome you to this panel. We got Jon-Paul Herron from ESNET, Alex Vanderhill from Surf, Jørgen Qvist from Nordunet, and Chris Wilkinson from Internet 2. And I would like to take the time to maybe do a little presentation on the 100 gig ANA pilot that was thought in 2012 and made reality in 2013. Back then, it was a collaboration between ESNET, Nordunet, SurfNet, Tata Communication, Internet 2, Canary, Géant for the purpose of that slide, but they were known under another name, Dante, and Ciena. And I was the representative of Ciena that actually was working on the link, so feel free to ask questions throughout the presentation, throughout the discussion. It's there for you to tell you a really cool story, I think. So, how did it start? This is a drawing that I think it was Eric Jan Boss and I that worked together, and we wanted to do together from a proof of concept point of view. We wanted to connect the 100 gig transponder, if you will, through a Tata submarine cable from New York, actually more New Jersey, onto Stratford, UK, then over the terrestrial route up into Maastricht. And the idea of that link was to demonstrate the capability to see if 100 gig was viable as a link through the 100 gig, through the transatlantic. Back then, 40 gig was already existing. There was 40 gig transmission to go across the Atlantic, but at 100 gig, it was very the beginning. And what you probably don't see in there is you see there were the 6500 shelf, which was the Nortel acquisition by Ciena. I was part of the Nortel crew. Then we had to transport that signal over a core stream system, which was Ciena technology, Ciena Classic, over the rest of a Tata based 6500 system, and then exiting through in Maastricht on time for TNC 2013. Obviously, no good design come from a discussion without a napkin diagram. So I want to let you know that we digged into a whole lot of history in there, and this is when we were talking about 100 gig ANA with some different path that we could take, and how we could interconnect. And basically, our panelists will be able to give us some really good insight on this if you desire. And the last slide I have, and this is where we're going to start the panel discussion, this is what it looks like right now. This is how we went from a pilot, we declared success, and and now the community the consortiums have now paved the way to have this wonderful interconnection between multiple cities across multiple paths. And I would like guys to start the panel with this question: is can you all give us your perspective on why you investigated that 100 gig link capability in the first place in the beginning. Jon-Paul, you can start. You have the microphone, but then go into the order that in which you want.
I can go first. Yeah. So for ESNET, the main driver here was some changes going on with the LHC project in CERN, and the need that they were asking us to help support them, and that was the main, I guess, bandwidth driver. But beyond that, I think what was really interesting to us is being part of kind of this was the first time anybody had done this sort of community-built shared infrastructure at this level with so many parties. And so I think for us that was a big part of it too. I think that's been kind of a theme of the week, is sort of the strength of this community is community, honestly, and being able to do something together like that was a huge part of it for ESNet. So I think we were interested in, like, how do we work together to build something that's impactful and efficient and forms closer relationships.
I will. Yeah. That's not a single question for me. It's not a single answer. It's sort of a chain, not a same moment, same moment in time. Back then we had 700 gig links, 10 gigs I must say, across the Atlantic, and multiple vendors, multiple suppliers, different endpoints there. But I think it was in May 2012 that we were here at this event, but then in Arlington, that a few of us sat together with that idea of building the first 100 gig link across the Atlantic. You were there for sure. Eric Jan Bos, he got us a royal honors last week.
That's
partly
true.
for this.
That's true.
Partly for this.
Yes.
Edward in the back there, he was there for sure. My CEO back then, Kees Neggers, was there. And Kees was not afraid of doing moonshot projects like this. So he really wanted us to be successful with this first 100 gig link across the Atlantic. And that first link to Maastricht was not a lot more than a pilot, showing off that we could get things done there. So really amazing. But right after that, I think we wanted more. And it was Internet 2, it was Canary, it was Surf and Nordunet that said, hey, we want to make that first 100 gig link the production link. So we did that somewhere half a year later, I think. Very simple way, on a sort of gentleman's agreement, we tried to share the cost there. A bit after that, we started building the second link, a more pragmatic way of sharing the cost with that. Canary and Internet 2 shared the first link. Well, that's from a little later.
Yeah, even later.
Yeah.
That was the results of the pilot. After the pilot was declared success, I guess, right?
So I think the link from Amsterdam into New York then was paid by. I'm going back in memory lane now, by Nordunet and Surf, and the link from London into Washington back then was paid by Canary and Internet 2. That evolved a year later on. Jørgen joined the club, and then this diagram came to life, and they built that link from Paris into New York. And a little bit later, we also opened the first open exchange point in Canada. And then right after that, I think Nordunet and Surf moved their link to Canada instead of New York, and that was this system here on the page.
Yes. I agree. Chris, would you like to add something, or Jørgen?
Oh, I would just say that I go flip back one more slide, Marc. I think there was a lot of different partnerships that went into the creation of this initial link as well. It wasn't just the submarine segment, for example, that was a huge challenge. There were terrestrial segments as well that had to be built, maintained, and this link came up for a time and then went back down again, but it was really the driver for everything that came after it. The other note that I had was that this was a very deep industry partnership as well, that in addition to the work that the community did, several different parts of industry stepped up, including Ciena, Tata, to get this link online.
Yeah, the one part of the industry is Tata and Ciena. We wanted to show the world that you can mix and match together 10 gig traffic with 100 gig. There was a lot of, I wouldn't say misinformation, but negative information about mixing amplitude modulation with coherent modulation. It actually was very difficult to do it. So we learned a whole lot of lessons in there as well. Tata learned a whole lot of lessons. I think this is one of the first time we actually experienced 32A of A as well in terms of interconnecting the submarine connection. And that was not necessarily very pleasant either. Jørgen?
Yeah, if you fast forward to the next slide with a napkin. I think this, the whole thing where ANA has changed the game is really that it is a system. If you look back when it was all 10 gigs, there were loads of 10 gig that individual organizations has bought, but the thing was getting redundancy enough. So a lot of individual circuits, but no generic thinking about redundancy. And this is where you see this design here, is basically where we actually worked together on making sure that we procured things together that were redundant. We were building a system, so in principle, once you add in the open exchanges, you could basically connect to anywhere in the system, to anywhere else in the system, and making sure you had that redundancy. And the reason why there were 4 links initially was a lengthy discussions with Inder from ESNET about what it will it actually take to ensure that you have 100% uptime. If you look at stuff and the length of the cables and the times of repairs, there was some interesting calculations that made us arrive at 4 was a good number. So, but so far it had worked out. So was not a bad calculation after all. So I think that is really where the system sort is, for me, the main thing that made the difference is that we share the capacity, and then by doing that we can actually create the needed redundancy for everyone that's involved. And I think that was the key thing, and that is what created the ANA sort. And I think the ANA acted as a pathfinder for a lot of the other collaborations that we see around the world about sharing capacity. And that is, for me, is one of the key things that this project actually did achieve, that it created a way of actually working together, saving money for everyone, but retaining significant redundancy. So I think that's the key thing that came out of the ANA.
And that was a new business model that you were learning to deal with those submarine big channels. You were starting those consortiums. Again, you're maintaining this. One of the very first time, me from an industry perspective, that we were even looking at alternative path, redundancy. These were not natural discussion that we had with the community. So that really was a big difference maker.
I think that's funny, because the first contract that we did with Tata was the cost of 100 gig was just 10 times the 10 gig. So we didn't save a lot of money. But all the steps afterwards, we were saving money, renewing the contracts, and in between also we realized that instead of going for shorter term 3 or 5 year contracts, we could do IRUs as well. And that saved us a lot of money, and getting a resilient system, or an inherently resilient system, I would say, in return for that.
And when you say about the cost model, I think it went down to a fraction of the cost. I think around 3 or 4 times the price of a 10 gig. You had 10 times the bandwidth, so you really change the exchange between the two continents.
Absolutely, yeah.
So, sorry. So, we're starting to talk about what it means to you in terms of perspective for your organization. How did it change to interwork together? as a community. And obviously, after we've done this, we did the same across the Pacific. I remember doing from Queenstown, New Zealand, to LA, working with Andrew Lee. He's not here, but Andrew Lee worked a lot in there in LA. And we did the very first 100 gig across the Pacific. But so what does it mean to you now? If I go back to the last slide, this is a representation of the current ANA. There's 100 gig links, there's 400 gig links. What's in your perspective moving forward?
The first thing that came to mind when I saw this and actually realized how many links there are, we're getting back to the 10 gig scenario. So that is definitely a consideration, but it's also, we are in a transition period also, where you're transitioning from 100 to 400 gig to higher speeds. So, but right now there's a lot of links, and there's a lot of links, which is good because links means redundancy, but it's also a question of consolidating, but it's also probably a sign of that we use a lot more capacity. So even if you're going to 400 gig, 4 links are not sufficient. So it's also a sign of that you're spending a lot more time and also to organize the whole thing, because it is, the more links it gets, the more complicated it gets. There's a higher need for making sure that the failover scenarios actually works. So it is more complicated now than it was back when it was 4 links, but it's probably unavoidable given that the capacity is not as such that we can live with a couple of 400 gigs or a couple of 800 gigs even. So I do believe that complexity is something we will have to look at and address how to going forward, because as you can see, there is a lot of links and there's a lot of things to look out for. So I think that's the first thing that struck me when I actually realized how many there were.
But still there's a difference, Jørgen. Back in the days, ANA let us leave the days that everybody did their own thing. Yeah. We had our own links, you had your own links, and now we still procure these things in an organized way. We have those GXPs, the global exchange points interconnecting the system, and with all this other system that you just mentioned, AER and APONet, we have a world-spanning federal network, the GRAN as we call it, and we're getting much better in articulating what that means for science, I think. When we talk to SK, we now can say, hey, just go to your local NRAN, they will deal it with the other NRANs in the GRAN, and we'll get it done.
Yeah, I was going to add to that and say, you know, just as 10 years ago we were switching from, say, 10 gig Sonnet, experimenting with 100 gig E, you know, making that technical transition, I think we're at a technical transition point again, moving into the optical spectrum era. And I think, again, with the ANA group here, we're doing some pathfinding with that and how we can, again, affect the economics just as we did 10 years ago, and in looking at what do the economics look like in a spectrum world. So if we're, you know, we're enabling, you know, tens of terabits potentially in the future, and able to really drive down that cost and still have all of the bandwidth we need across, you know, 8, 12, whatever the number is that we end up with links. And so it feels like we're, you know, we're sort of repeating a new transition point technically here.
That's true. In another year, there'll be a third type of line on this map, and it will be spectrum. And there will be another exchange point inside the United States where that spectrum lands. So this map will continue to evolve with the new technologies that come online. I think one thing also that's not shown on this map is there's no perspective of the cable systems. So there's an entire level of coordination that goes on, again, inside the consortium about which links come through which cables, and trying to optimize that structure so that a single cable cut doesn't take down a large number of links in the system. So in the previous map, the cables are actually noted. If we collapsed this one, it would get even more interesting.
What I think is really interesting as well is that because the cable changed, the consumption model were lease circuits, right? Yes, you had to pay for your transponder, but you didn't control it. Now with the spectrum leasing, you're making a better proposal at the beginning of a build of a brand new cable, and you can actually make speculation not only about the line rate, but how much capacity you have, and what is your new reality thinking and changing the way you're thinking, right? You're going from bandwidth to spectrum. Does it, well, first and foremost, does it change the way you orchestrate the bandwidth? Did it influence the way that you're building your network from a terrestrial part? Can you give us some insight on what's ahead for you in terms of technology and how you will proceed to either replace or upgrade those capacity using those spectrum capability?
I guess I would say the main thing, technically speaking, you're bringing your own transponders, and so there's some element of engineering that needs to be done to do that. But really, what it enables is, unlike a lease line where if you're trying to share that, you do it at a higher layer where you're sort of doing routing to share that, or maybe trying to share equipment. Spectrum makes it much easier than that. So if you have spectrum and you want to share it, so what we're working on right now is a shared system with Géant, where ESNET is purchasing spectrum across 2 cables, Géant's purchasing spectrum across 2 other cables, and then we're sort of swapping with each other so that we have, we can spread our bandwidth across 4 cables and integrating that with the entire ANA. And so that capability makes it much easier to get added resilience while you're still maintaining control for yourself. So when we do this with Géant or anybody else, we could light more spectrum and share it with others. It's up to each network to decide what kind of hardware they want. They can put whatever transponder they want and light it however they want, and the level of, there's not as much friction or interdependence to make that possible. So you sort of open it up so that you're it makes it very easy to get the efficiency of sharing that very expensive resource without having to give up control or letting each network use whatever kind of hardware they'd like.
Anybody have other insight about the spectrum sharing? Or?
Yeah, that's something we, Nordunet and Surf, developed on the European end on one of the cross-border fibers that we shared, and I think it's amazing to see that we see that concept now also crossing the ocean here. So that's a super development.
Yeah, I agree. I mean, we did the first test on spectrum sharing or alien wavelengths or whatever you want to call it back on the 10 gig days, where it was quite complicated. With the coherent technology, it has become a lot easier, and now it's like it's commercially available, which was not the case just going like 3 years back. It's really something new that the operators that are deploying the new cable system are also deploying them in a way where you can actually use the spectrum in that way. And that has to do with the SLTEs being built in a different way it's possible to do, so you have your own optical domain inside the cable system itself. So that is new. We've been working with it on the terrestrial basis together with Ciena and SurfNet and others at the European level, where we, at least from our perspective, have cost significantly down on the mileage of fiber that we actually own and manage. We still have the same network coverage, but we do not own the same amount of fibers anymore. So that's there used to be quite an overlay between some of the networks like ours and Ciena's, for instance, and that has basically gone away in this new era. And as Ciena has just renewed all of their network and have bought new fibers where they need to buy new fibers, that has basically mean that when some of our IRUs are running out, we're not going to renew them, that we're just going to use spectrum on Ciena's network. And likewise for the Nordics, Ciena is using spectrum on our network. So everyone is saving money by using that technology, by, as you said, maintaining control over your network.
I think that's a really good point, and I think entering into an era where efficiency and doing things in a cost-effective way is so important. I think this will be a major opportunity for not just transatlantic, but also let's say domestically within the U.S. or anywhere else, that we as a community can do a lot more of this sharing, and I think get a lot more capability for a lot less money.
Yeah, and we've certainly started to see some of that, as you're indicating, inside the domestic U.S. Additional spectrum sharing between entities. It also allows you to push the edge on the technology side as well. So you're not locked in necessarily with a certain vendor or a certain line rate or a certain architecture. And so you can evolve the network kind of as technology emerges. And maybe you're not stuck with Ciena. Oh, I mean...
That's true. The spectrum sharing make it a little bit more open, and that's something that's really important because, like you were saying, each countries may have a different procurement model, and they may choose another vendor at their own risk, of course. But I mean, but I mean, Can you guys comment on how do you see we influence the rest of the globe in terms of interconnecting islands? Example, Hawaii, for example, the Pacific. Did it actually open up more economical ways to have alternative path to other countries or other communities that otherwise you would not have had with the advance of the technology?
Well, yeah, it's not only technology, it's also market, I think. The Atlantic has always been an affordable market, I think. When you look at the Pacific, it's way more expensive than this. But we started with this, and what I just mentioned earlier, the way from shortened contracts to RUs brought us a lot. And that also gave us the opportunity, for example, to build or to procure a link from London to Singapore later on in the AER initiative. That was for us a groundbreaking thing to move towards the east instead of the west, and then onwards to Asia. So it was a good thing for us from a European perspective. For me, the move to spectrum also comes with a question around the GXPs. These are built now on layer 3, layer 2 mainly. How do we adapt the GXPs to a spectrum world? And we need to think about that, I think.
Yeah, I think even in our case, the GXPs are linked by spectrum domestically. We use coherent optics in several locations to link GXPs. Those are using spectrum as well. Yeah.
Does this GXP become a spectrum exchange then?
Maybe down the road.
We are not there yet. I don't think that we have the answer today, but we need to start thinking about that.
Well, I was kind of thinking of a variant of that as well. For example, in the Pacific, spectrum can really come into play. There's things called branching units that allow you to add and drop spectrum in specific places and pick that spectrum back up and send it in the other direction. I mean, we've seen that in the domestic US. We add branching units sometimes in our own DWDM system to add and drop not just capacity, but connectivity going various places. So that, I think, could repeat in the submarine world as well.
Yeah, now there's one development that we've seen technology-wise that's also changing the picture. Right now we're seeing it in the metro and the regional networks where basically you remove some optical components from your network by putting the transponder directly into the IP router. And that is something that is also, that's the next wave of really doing something that's cost efficient. And it's there for metro, it's there for some parts of the regionals, depending on reach. And eventually it might also be there for the ultra long haul, but then again, then there are some power designs in the routers that needs to change. But I think that is probably one of the next things that I'm expecting to see is that will also happen on the long haul side, that you can actually put the transponder directly in your layer 3 equipment, whatever that may be.
Oh, we did a shot domestically at 3,000 kilometers. You know, it's about halfway. So maybe in a few generations we'll get there, technology generations.
The vendors are working hard on this.
We as a community here are very passionate about technology, but I think the reason we do all this is the impact for science, and we made that a lot easier with things like this. Years back when I just started at SURF, we were always thinking about, oh, what is the amount of cost that we need to bring to the researcher here, but also things like that made this much easier. The capacity is there. We don't argue too much more about who pays what, so it's very easily accessible for scientists and for education in our countries across the globe. So I'm happy with that.
I would add, I think one of the other ways that ANA has been influential in other areas to work off of what you're saying is it's not just about technology. It is also about how do you organize a group to work together on something like this. I think we all work very well together, but we're not homogenous, right? Every network has their own needs, has their own limitations and their requirements. So how do you work together as a consortium to work through that to still build the system that works for everybody who is involved? And it's easy to talk about the technology, but I think one of the major successes of ANA is just how we've been able to work together to make it work. And there's lessons there for the rest of the world.
Absolutely support that. This looks like an easy picture, but even this week we were sitting together and we argue about the simplest things. And you have to learn how to do that together and to get the common understanding of what you're doing and common wording for that. Yeah.
You look like you're getting along, but that's not always the case.
We're kicking each other under the table.
Yes, I know. There's a reason why. One other thing that might be entertaining for the group here is to talk about the wonderful world of fiber cut.
The most exciting topic.
We have to be entertained. Yeah, can you comment on the wonderful world of fiber cut and how did it change your perspective on the submarine, especially in the Atlantic? And in the Atlantic, there's a lot of fishing going on, geopolitical conflicts that may or may not be suspect. How did it affect the reliability of that connection, and how did it affect as well how much of that extra capacity that's driving the link between the two main continents?
Well, back to 2013, remember, when we had only that first 100 gig link that was traversing the North Sea as well, and the North Sea is very shallow water. Yeah. So by accident, sometimes that cable break. I think in the first year it broke 4 times, something like that. So we didn't remove our 10 gig links before we got a second one in place. So, and that's brought the system brought us that as well, that more resiliency there. And
And I guess I'd add not just that the frequency is there, but the time it takes to repair them is so much higher, right? With a regular, let's say, terrestrial fiber cut, you might be spending 8 hours waiting for that to be fixed. It might be 8 weeks waiting for somebody to fix one of these cables. You have to get a boat, you have to get the permits to make sure it's in a shipping channel. It might be even longer. It's much more complicated to do that. And what that means, I think, is you have to basically, instead of assuming you'll have 1 down at a time, or maybe even 2 down, you might have to assume the failure mode where you have 2, maybe even 3 cables cut at the same time, and make sure that you can carry all of this critical science traffic in that scenario.
And that happens. This topic is about ANA and not about AER, the other system that we have. But last year, I think we had 4 cable cuts at once, and the traffic was still flowing because of the collaboration that we have within that within the system.
With that drive, with the open spectrum, would that drive moving the traffic on the available spectrum? Are you forcing a new architecture change that you're thinking about or asking the industry to figure it out? I mean, with so many cables like that, do you have like a protection schemes that said, okay, while this link is likely going to be down for 3 months, can I use the extra spectrum that's not being used right now to deal with the current outage? What do you think about something of that category or that sort of ideas?
Well, I think the first thing to consider here is that one thing that had happened with that there's so many cables now, and there has been from the industry, there have been a lack of investment in cable repair ships. Mm-hmm. That basically means that your cable repair times has doubled, in some cases even more than that. And that means that the calculation about 4 being a good number is probably different today, simply because the repairs take longer. And there are other considerations. Now I come from the Nordics, and we have quite a few cable systems in the Baltic Sea, and there we have seen a couple of occasions where ships have sailed hundreds of miles with the anchor down, going across several cable systems. So the number 4 in these high-risk areas is probably not good enough anymore. So that is a consideration, if it's geopolitical or it's simply because the cable repairs take longer nowadays. Either way, it's something to consider. What is the real good number that ensures that you have this capacity? And it's clear that the spectrum thing that we see across the Atlantic, where several organizations is buying spectrum, a lot more spectrum that they need initially, yes, it provides the opportunity, if there's a lengthy outage, that you can actually move capacity off and onto this free spectrum. So it provides us with opportunities to do something like this. But it's a real fact of life that there are more cable cuts and there are longer cable repair times that you need to take into consideration.
And I think many of these cables are still designed and built individually. They don't tend to be, you may feel differently, but they don't tend to be, for example, like you would have your endpoints, Marc, and you would have multiple cables that you can just switch. Usually there's geographic separation between the cable landing stations, and each cable landing station is discrete with its own terrestrial backhaul. So the industry still has a long way to go before you get to some of the things I think you were hinting at about automatic spectrum switching. All of that is still being done by these consortiums at a higher level. So for us to switch traffic from one cable to another, it may still involve everyone at this table and even more folks who aren't here representing us today. There's several organizations that aren't here today, and we all work together to ensure that capacity moves through the system in the best way possible, under any circumstance, hopefully.
And I guess the last thing I would add is that all of that is adding complexity, which means there's a whole lot of engineering that goes on to understand what the failure modes are and how traffic will behave in those failure modes. And so it's not quite as easy as just like the traffic will go where it needs to necessarily. You have to understand how much traffic is going where. And if you add the features you're talking about where, might be lighting extra spectrum in other areas, that makes it's another layer of engineering that has to be done to understand how the system will behave during.
You get a lot of bright people. I'm sure you're going to be able to figure it out. Does anybody have any question in the audience? Because I have more, but we would like to know if there's a topic that you would like us to explore or discuss. It's free. Okay, well, I have another one. One of the questions that is really interesting for me is When I was at PTC this year, some of you were there, we were seeing some other cables being laid out in different areas of the globe to actually mitigate those famous fiber cut by metallic life forms. And one of the characteristics of those links is they have higher latency. Do you have any opinion on what it would do? What would you prefer, a higher latency link for quite a while over a 3-month outage? How would you perceive that? And my follow-up question is, there's a finite numbers of boats. Those boats are aging. They're not building any more boats because they're expensive. So there will be more and more, unfortunately, wait time as the number of cable will increase and need to be repaired. So how do you prepare for the future based on those extra cable with a different unnatural distance in between the continents?
Well, the area where we live, submarine cables are in the news almost every day, every week. So that's good for the public opinion. Everybody knows what submarine cables now are. And everybody knows that we need to invest in new vessels. Even icebreakers are in the news these days, that we need to build them. So a project what this guy is working on is a new route over the North Pole. And these links are shorter, I think, towards Japan at least. So no longer latencies for that. And that's from a European perspective, gives us more resiliency towards the east. Because most of the cables are now running through the Suez Canal area, and when the cables cut a little bit below there, close to Djibouti, you also have a problem to repair there because of the dangerous area. So.
It's Canal de Suez right now. The cables are being cut and abandoned by the operator because there's no crew, no boats that wants to be sacrificed over that conflict over there. So. This is one example where we favor the boat over the cable. So that's why there's new cable. For example, between Africa, South America, back to Australia and New Zealand, or reverse order. But there's a long route in the southern part of the globe, and I know our friends from Singapore, Singer, and for example, experience out of 7 fibers in the same day, 6 fiber cut, and they only have 1 cable length, so they're really looking at alternative, and it's been 9 months they're looking for those 6 cables to be repaired. So that gives you an idea of how critical these resources are and how long the wait time is.
And I think if you consider where the Herron is located, I think if you look at all those new specifically the new Meta announcement and what Google has planned in the Southern Hemisphere, it all has some similarities about that. It's definitely trying to avoid the South China Sea, for instance, because it's impossible to get to repairs there. And again, from a European perspective, traversing or getting to Asia at this point in time is problematic. There is a terrestrial route across Russia that no one is using anymore. And then there's multiple cable systems that all, as Alexander said, is all in the same place. And some of them are damaged and cannot be repaired at the moment. So actually, as we speak, there are traffic from Europe towards Asia that's actually going over the US to Asia, which comes with a heavy latency penalty. So when you talk about latency versus availability, yes, availability is probably more important than latency, but if you start calculating the latency from Europe over the US and the Pacific onto Asia, it is significant. It's like 370 milliseconds, and it's not desirable.
All right, well, there's 5 minutes left to this panel. Really touting again the audience here. We made this panel for you. Any question? Still free. Thank you, Ed.
I'll just ask one. I don't know if this is on. Question I have is, yeah, someone obviously dragging boat anchors, potentially geopolitically motivated, perhaps drunk captain. Yeah, they'll argue about that, right? What other geopolitical risks do you see to this type of collaboration that you need to engineer around, that you see evolving perhaps in the recent past few years?
I can answer that, but I'll let you answer that.
Absolutely a topic we talk about, of course, and we spread our risks for that, I think. So, and that's about the Suez Canal area is a risk. The ownership of the cable could be a risk. The places that you land could be a risk. So spreading is the trick.
I would add as well that there are some, especially where the Canal Suez is there are some companies that have exclusive access to those cables, and they are on the blacklist of the U.S. government. So regardless that you want that boat, you've got the money, you're not allowed as a U.S. or making business with U.S. to interact with these entities. And even if it's a brand new cable that you would like to go up that geography, there's only two countries that control the access, and a lot of money. Fortunately, they're not entities that U.S. entities can trade because they're on the blacklist. They're the bad guys. You're not allowed to give them money. So, anybody else have anything to say? So, thank you very much. This is the last session. We're very happy to have you participate today. Thank you. Thank you to the panelists. I would close the panel right now, and thank you all for your time.